Hi, this is Calandra. In this video, we'll cover an application that deals with area. In our first example, we have the length of a rectangle is 3 meters longer than twice its width. Its area is 20 square meters. Find the dimensions of the rectangle. Whenever possible, I like to draw a picture to help me visualize what we're talking about. So I'm going to start off with my rectangle. And we know that the length is 3 meters longer than twice its width. So let's call its width W. Then I know that the length is 3 meters longer than, so that means I'm adding 3 to something. 3 meters longer than twice its width. Well, twice the width means we're multiplying it times 2. All right, so that expression would represent our length. We have that the area of this rectangle is 20 square meters. So this is when we need to remember what is our formula for the area of a rectangle. Okay, and that formula is length times width. So we can get our equation by taking our length times the width, 2w plus 3 times w, and that will equal the area, which is 20. So to figure out our dimensions, we need to solve this equation. So the first thing we need to do is to distribute that w to get rid of our parentheses. So we have 2w squared plus 3w. And I know I'm going to need 0 on one side of my equation, so I'm going to subtract over the 20 so that I have all of this equal to 0. And now we need to solve our quadratic equation. I'm going to solve it using quadratic formula. So I need to identify my a, b, and c. A is 2, b is 3, and c is negative 20. So for my quadratic formula, I'll have that w, since that's the variable we're using, is equal to, okay, let me write our formula and then we'll plug our values in. The opposite of b plus or minus the square root of b squared minus 4ac divided by 2 times a. So for us, this will equal the opposite of b, which is negative 3, plus or minus the square root. B squared is 9, minus 4 times a times c is negative 40, all divided by 2 times a, which will be 2 times 2, or 4. So now we just need to simplify our radical, or the radicand. Negative 3 plus or minus the square root. And I'm just entering this in my calculator to keep from making an arithmetic mistake. 9 minus 4 times negative 40 gives me 169, all divided by 4. Okay, 169 is a perfect square. It's equal to 13. So we end up with 3 plus or minus 13, all divided by 4. So this is 2 different answers. We have the positive, the plus case, and the minus case. So 3 plus 13 over 4, and 3 minus 13 over 4. So if you're putting this into your calculator in one step, just make sure you put parentheses around the numerator, because we know that we want that operation to happen before dividing by 4. Okay, so in the top we end up with 16 divided by 4, which is 4. The bottom we have a negative 10 over 4, which simplifies to a negative 5 over 2. Okay, so let's look and see what we're looking for. We want the dimensions of the rectangle, so we're looking for the length and the width. what we just found are the possible values of the width. But width has to be positive. You can't have a negative width or length. So we can reject the negative 5.2, and our width must equal 4 meters. To find the length, we just plug the 4 in. So we get 2 times 4, which is 8, plus 3 is 11. So our dimensions would be 4 meters by 11 meters. Going on to our next example. A sidewalk of uniform width is being constructed around a community pool that measures 25 meters by 50 meters. Okay, so let's draw a picture before we go any further. So there's a community pool. Oops. Don't want to color outside of the lines. And a walkway is being built around it of uniform width. Okay. Does that make sense? Have some kind of concrete walkway going around the whole thing. And we're told that the pool measures 25 by 50. Okay, so we'll let this represent 25 meters, and this side down here will be 50 meters. If the total area of the walkway is 664 square meters, how wide is the walkway? Round your answer to the nearest tenth, if applicable. So we're trying to figure out how wide our walkway is. So we can assign a variable to that. Let's call it x. So we know that the width of the walkway is uniform. So on each side, I know that width will be x meters. The other information that we haven't used yet is the area of the walkway. Well, notice that the shape of the walkway is not a rectangle. It's actually a rectangle with the pool area having to be removed from that. So I need an expression for the area of the walkway. The first thing that we need to do is to get an expression that represents the length and the width of this walkway. So if I start with my width, I know the width of the pool is 25 meters. On each side, I know that x meters are being added onto it for the walkway. So that means my total width will be 25 plus 2x. Right, 25 plus x plus another x gives us 2x. Similarly, I know that the length of my pool is 50 meters. I'm adding x meters on either side, so this entire length will be 50 plus 2x. So now we can get some expressions for our area. So the area of the big triangle, or rectangle, will still follow our length times width formula. So we'll have 50 plus 2x times 25 plus 2x. But that's not the area of our walkway because that also includes the pool. So what we have to do is subtract the pool area. So minus the area of the pool. So that will just be length times width. So we're subtracting 50 times 25. And what we're left with then is the area of the walkway, which is what we want. And we're told that that area is 664 square meters. So we can set this equal to 664. Okay, so that was the hardest part of the problem, just coming up with our equation. So now we need to multiply this out and get this into a form that we can solve it. Okay, so first we need to get rid of our parentheses. So I'm using FOIL to multiply it out. So 50 times 25 gives me 1250. Outer times outer gives me 100x. Inner times inner gives me 50x. Last times last gives me 2x squared. Then we have minus, again, 50 times 25 is 1250. And we have all of this equal to 664. Okay, so our 1250s are going to cancel out. And it looks like we have 2x squared. I'll write it in descending order of powers. 100x plus 50x is 150x. And since I'm dealing with a quadratic, I know I want 0 on one side of my equation, so I'm going to subtract over 664. And now we have that's equal to 0. So at this point we can solve using quadratic equation. But to make our work a little bit easier, notice that each of our terms could be divided by 2. So what I'm going to do to make our numbers a little bit smaller, I'm going to divide both sides of my equation by 2. So remember, that means you need to multiply or divide every single term on the left side by 2, and that will give us x squared plus 75x minus 332 equals 0 divided by 2 is just 0. So now to use our quadratic formula, identify your a, b, and c. A is 1, b is 75, and c is negative 332. So applying our formula, x is equal to, let's write that formula out, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So this will equal the opposite of 75 plus or minus the square root of 75 squared, which I'm typing in my calculator to get 5625, minus 4 times a times c will be negative 332, all divided by 2 times a, 2 times 1, which is just 2. Okay, so this will equal negative 75 plus or minus, and now I just need an expression for my radicand. So I have 5625 minus 4 times negative 332 is 6953, all divided by 2. So we have two possible answers, one with the addition and one with the subtraction. So negative 75 plus the square root of 6953, all divided by 2. And then negative 75 minus the square root of 6953, all over 2. Now keep in mind that x represents the width of our walkway. So we know that x has to be a positive value. If you look at the second expression, negative 75 minus whatever we get here is going to end up being a negative value. So I can go ahead and reject the second case because it's going to be a negative. So we can just focus instead on the first quantity, and so we can use our calculator to come up with that. So when you put it in your calculator, if you do it in one step, you want to make sure you have parentheses around your numerator. So negative, open parenthesis, negative 75 plus the square root of 6953, close parenthesis, possibly close a second time if you had to close off your square root, divided by 2 is approximately, and let's see, the problem tells us to round to the nearest tenth. So this is approximately 4.2. Okay, so what are the units that we're dealing with? Looks like meters. So we were looking for the width of the walkway, and from our picture, we see the width is just x. When we use the quadratic formula, we came out with exactly what x is equal to. So it would be 4.2 meters.